So now I'm going to show you some examples of composite functions. So we've got two functions here, which are f of x, which is equal to 2x plus 1, and g of x, which is equal to x squared plus 2. So over here it says find h of x, which is equal to g of f of x. Okay, so we want to find h of x. So how are we going to think about this? Well, what you want to think about is you've got this term g, right? And if it was just x was equal to 2, we'd just put 2 in for every value of x. So that would be 2 squared plus 2, which should be 6. But instead of 2 being our input, we're actually using another function as our input. So what we're really going to have is g of f of x. Okay, so what we're going to do is every time we see an x, so now we're going to put in what's the value of f of x is. So this becomes g of 2x plus 1, right? And now every time we see an x in the function of g, we're going to replace it with 2x plus 1. So we're going to be left with 2x plus 1 all squared plus 2, right? So that's just a case of multiplying that out. Square the first term, so that's 4x squared. Put times the terms together and double them, so 4x plus 4x. Square the last term is just 1. 1 squared is 1 plus 1. This is all still in brackets. Plus 2. And that's your final answer here. You'll get 4x squared plus 4x plus 3. There you are, and that's your answer. Okay, but what about over here? When h of x is equal to f of g of x, well, I might even call this k of x instead, because that makes it a bit clearer. So what about k of x? If k of x is equal to f of g of x, right? So it's the other way around. So is this going to affect the result? Well, let's have a look. So you have f, and then you put in what g of x is. So you have x squared plus 2. Then every time you see an x in the f function, we're going to replace it with x squared plus 2. So this is going to equal 2 brackets x squared plus 2 plus 1. So when you multiply this out, it's 2x squared plus, well, 2 times 2 is 4, plus 1. So then this is going to be equal to 2x squared plus 5. And as you can see here, these two answers are different. You get different answers for the two different combinations. F of g of x is not equal to f of g of f of x. So they're not equal to each other. So two more examples. So here we have f of x is equal to x squared minus 2, and g of x is equal to 1 over x, where obviously x is not equal to 0. So here we're asked to find k of x, which equals g of f of x, and h of x, which is f of g of x. So if we do k of x first, k of x is equal to g of f of x, right? Well, what we want to do is write g, and then what we're going to have in here is whatever f of x is. So we have x squared minus 2. Then here we're going to substitute x squared minus 2 anywhere we see an x in g. So this ends up with 1 all over x squared minus 2. So that's it, that's your final answer. And then you have h of x, which is equal to f of g of x. Okay, so we have f, and then we put whatever g of x is in, so 1 over x. So now wherever we see a x in the function of f, we're going to replace it with this 1 over x. So this becomes 1 over x all squared minus 2. You can simplify this as 1 over x squared minus 2. That's your final answer there. Your final answer there.